Hey, this is going to be notes for week 3, lesson 8. They are about completing the square. So some review of that and combining it with some review of that square root method for solving, right? So if we were asked to solve this quadratic x squared minus 16x plus 15 equals y, I'm going to show you two methods for doing that, all right? So we'll write this again, but instead of y, we're going to substitute 0. Because that's where the solutions, the roots, the x-intercept when y equals 0, right? All right, I've kind of got this set up for us to work on completing the square here. So this would be a nice perfect square trinomial if it weren't for this, right? So remember our strategy could be to come over here, create this little box, split negative 16 equally, negative 16x, excuse me. That's what's going to make it square. And that would make the binomial on each side, that x minus 8. And so negative 8 times negative 8, we would add 64 here, right? We would also immediately take off 64. Now, why do we do all that? Because it was that 15 that was making it not perfect. That's why we kind of kicked it outside, made a perfect square here. So technically what we had is x squared minus 16x. We added 64. And we also subtracted it because we want to maintain the integrity of what it originally represents. And now it all equals 0. Why do that? Because I can express this as a perfect square, x minus 8 squared. And this part is going to be negative 49. I'm going to take a minute and just add up here. What's the point of doing that? Why complete the square? Well, it puts it in vertex form. In vertex form, allows us to isolate the square expression by doing inverse operations. So that's the case. I want to isolate this perfect square of x minus 8. I'm going to add 49 to both sides of this equation. Excuse me. And now I've done that, I've isolated the square, I can take the square root of that on both sides. So these will cancel out, squaring, square rooting. I get x minus 8 equals, don't forget, positive and negative 7. And so this is going to have two solutions, right? It means it's going to intersect the x-axis twice. I'm going to solve it by saying x minus 8 equals positive 7. And then I'm going to solve it again over here. Say x minus 8 equals negative 7. Okay, so we'll add 8 both sides here. Same here. Right? And now I'm going to have x equals 15. And over here, x equals 1. So if we write that as a solution set, I like to do them in order. Is how you'd see them again on the graph. 1 and 15 are the x-intercepts. You could write 15 when y is 0, x is 15. And it's also 1 because it crosses the x-axis twice. Okay, I'm sorry I didn't even show you any of that. Now, what we're using here, right, this part right here is called the zero property of equality. That if I add 0, I don't change something's equality. Right, So that's the first method, right? We go over here and talk about the second method. This is kind of faster in my mind, but we couldn't do it before because we didn't have equations. We only had expressions, okay? And that is to get rid of this 15 by moving it to the other side. So I'm still going to complete the square. This is, instead of kicking it out of the box, so to speak, I'm going to kick it out of the left side of the equation and just move it over to the right side of the equation. And so what I'm left with is x squared minus 16x equals negative 15. Now guess what I have room to add? Here I can add what made it a perfect square? 64. And if I do it to the left side, I have to do it to the right. And so now what we're doing is an addition property of equality. If I add it to the left side, I have to add it to the right. I don't think I left myself enough room to write that over here. So what do we have? X squared minus 16x plus 64 equals 49. Express this as a perfect square trinomial. And now you can see we're on the same path, right? I square root both sides. Now I'm at the same place as I was over here, right? So ditto, right? Okay. All right, my suggestion would be to stop right now and take a little bit break and then come on back and we'll do a couple examples together.